Installing a step-down transformer, specifically from 480 volts to 120/208 volts, inside the ceiling cavity of a computer room introduces several potential code violations. These issues primarily revolve around accessibility, ventilation, fire safety, clearance requirements, temperature ratings, and grounding considerations. Let's delve into each of these areas in detail. Firstly, accessibility is a crucial aspect. The National Electrical Code, specifically Section 110.26 (c), mandates that all electrical equipment must be readily accessible for examination, maintenance, and eventual replacement. Concealing a transformer within a ceiling cavity inherently restricts access, making routine inspections, necessary repairs, or complete replacements significantly more difficult and potentially hazardous. The code prioritizes easy access to ensure the safety of personnel working on or around electrical equipment and to facilitate timely maintenance, preventing potential malfunctions or safety hazards. Secondly, ventilation is paramount when dealing with transformers. Transformers, by their nature, generate heat during operation due to core losses and winding resistance. Confining a transformer in an enclosed space like a ceiling cavity, without providing adequate ventilation, can lead to a dangerous buildup of heat. This overheating can degrade the transformer's insulation, reduce its operational lifespan, and, in extreme cases, create a fire hazard. Sufficient ventilation allows for the dissipation of heat, maintaining the transformer's operating temperature within safe limits and ensuring its reliable and long-term performance. Thirdly, fire safety is of utmost concern, especially in environments like computer rooms. The National Electrical Code Section 300.22 (c) explicitly prohibits the installation of transformers in spaces that contain flammable materials. Computer rooms are typically laden with a high concentration of cables, wiring, and other combustible materials. In the event of a transformer malfunction or overheating, the presence of these flammable materials significantly increases the risk of a fire spreading rapidly and causing extensive damage. Therefore, installing a transformer in such an environment directly contradicts fire safety regulations and poses a substantial hazard. Fourthly, clearance requirements are essential for preventing fire hazards and ensuring safe operation. The National Electrical Code Section 450.21 stipulates minimum clearance distances between transformers and any adjacent combustible materials, while 450.13 refers to transformer vault clearances. These clearances are designed to prevent the spread of fire in the event of a transformer fault and to allow for sufficient airflow around the transformer, aiding in heat dissipation. A typical requirement is a minimum clearance of 3 feet from transformers to combustible materials. Installing a transformer within a confined ceiling cavity may not provide the necessary clearance, thereby violating safety codes and increasing the risk of fire. Fifthly, temperature ratings must be carefully considered. The National Electrical Code Section 450.45 (a) mandates that transformers be appropriately rated for the maximum ambient temperature of the environment in which they are installed. Ceiling cavities, particularly in computer rooms, are often subject to elevated temperatures due to the concentration of heat-generating equipment. If the transformer's temperature rating is lower than the actual ambient temperature in the ceiling cavity, the transformer's performance and lifespan can be significantly compromised. Overheating can lead to insulation breakdown, reduced efficiency, and potential failure. Selecting a transformer with an adequate temperature rating ensures reliable operation and prevents premature failure. Sixthly, proper grounding is crucial for safety and equipment protection. The National Electrical Code Section 250.20 outlines the requirements for grounding electrical systems. Specifically, Section 250.28 (d) addresses the grounding of transformers. Proper grounding provides a low-impedance path for fault currents, allowing protective devices like circuit breakers or fuses to quickly interrupt the circuit in the event of a ground fault. Installing a transformer in a ceiling cavity can complicate the process of ensuring proper grounding. Limited access and the presence of other equipment can make it difficult to establish a reliable and effective ground connection. Inadequate grounding can lead to dangerous voltage potentials and increase the risk of electrical shock or equipment damage. Given these potential code issues, alternative solutions should be considered. One viable option is to install the step-down transformer in a separate, readily accessible enclosure located outside the ceiling cavity. This approach ensures compliance with accessibility requirements and simplifies maintenance and repairs. Another alternative is to utilize a dry-type transformer with a low voltage winding that is already rated for 120/208 volts. This eliminates the need for a step-down transformer altogether, simplifying the installation and avoiding the associated code compliance challenges. A third possibility is to install the transformer within a raised floor system, provided that the system offers adequate ventilation and accessibility. Raised floor systems are commonly used in computer rooms to manage cabling and provide cooling. Installing the transformer in this space can offer a practical and code-compliant solution. Considering these alternative solutions and adhering to the National Electrical Code guidelines are essential for ensuring a safe and compliant installation. It is strongly recommended to consult with a licensed electrician who possesses the expertise to assess the specific site conditions, understand the applicable codes and regulations, and determine the most appropriate and safe method for installing the step-down transformer in the computer room. A licensed electrician can conduct a thorough evaluation of the electrical system, identify potential hazards, and provide recommendations that prioritize safety and code compliance. Ignoring these code issues and installing a transformer improperly can have serious consequences, including fire hazards, electrical shocks, and equipment damage. Prioritizing safety and seeking professional guidance are crucial steps in ensuring a reliable and code-compliant electrical installation. Remember that electrical codes are designed to protect people and property from electrical hazards. Adhering to these codes is not only a legal requirement, but also a fundamental responsibility. When in doubt, always consult with a qualified electrician or electrical engineer to ensure that your electrical installations meet all applicable safety standards. Furthermore, it is important to understand the specific requirements of your local electrical codes. Local codes may have additional requirements or restrictions that are not covered by the National Electrical Code. A licensed electrician will be familiar with these local codes and can ensure that your installation complies with all applicable regulations. Choosing the right type of transformer is also crucial for a safe and efficient installation. Dry-type transformers are commonly used in indoor applications because they do not require the use of oil or other flammable coolants. This reduces the risk of fire and makes them a safer option for computer rooms and other enclosed spaces. When selecting a transformer, it is important to consider its kVA rating, voltage rating, and temperature rating. The kVA rating should be sufficient to handle the load that the transformer will be supplying. The voltage rating should match the voltage of the incoming power supply and the voltage of the equipment that will be powered by the transformer. The temperature rating should be high enough to withstand the ambient temperature of the installation environment. In addition to these factors, it is also important to consider the transformer's efficiency. A more efficient transformer will consume less energy and generate less heat. This can save money on energy bills and reduce the risk of overheating. Proper installation and maintenance are also essential for ensuring the safe and reliable operation of a transformer. The transformer should be installed in a well-ventilated area and should be protected from moisture and dust. Regular inspections should be performed to check for any signs of damage or overheating. Any necessary repairs should be performed promptly by a qualified electrician. By following these guidelines, you can ensure that your step-down transformer is installed safely and in compliance with all applicable codes and regulations. Remember that electricity can be dangerous, so it is always best to err on the side of caution and seek professional assistance when working with electrical equipment. The National Electrical Code provides a comprehensive set of guidelines for electrical installations. It is essential to familiarize yourself with the relevant sections of the code before beginning any electrical work. The code is updated regularly, so it is important to ensure that you are using the most current version. In addition to the National Electrical Code, there may be other applicable standards and regulations. These may include local building codes, fire codes, and environmental regulations. It is important to check with your local authorities to determine which standards and regulations apply to your installation. When working with electrical equipment, it is essential to use proper safety precautions. Always wear appropriate personal protective equipment such as safety glasses, gloves, and insulated tools. Never work on live electrical circuits. Always energize the circuit before beginning any work. If you are not comfortable working with electrical equipment, it is best to hire a qualified electrician. A qualified electrician has the training and experience necessary to perform electrical work safely and in compliance with all applicable codes and regulations. Installing a step-down transformer in a computer room requires careful planning and execution. By following the guidelines outlined above and consulting with a qualified electrician, you can ensure that your installation is safe, code-compliant, and reliable. Remember that safety should always be your top priority when working with electrical equipment. Neglecting safety precautions can lead to serious injuries or even death. Take the time to plan your installation carefully and follow all applicable codes and regulations. If you have any questions or concerns, do not hesitate to seek professional assistance. The consequences of improper transformer installation can be severe, including but not limited to electrical fires, equipment failure, and electrical shock hazards. Therefore, diligence and adherence to established safety standards are paramount. Proper selection of the transformer, including its kVA rating, voltage rating, insulation class, and temperature rating, is critical. The transformer's kVA rating should be adequate to handle the anticipated load, with a safety margin to accommodate future expansion or unforeseen increases in demand. The voltage rating must match the supply voltage and the voltage requirements of the connected equipment. The insulation class should be appropriate for the operating environment, taking into consideration factors such as humidity, temperature, and potential contaminants. The temperature rating should be sufficient to ensure that the transformer operates within its safe temperature limits, even under full load conditions. In addition to selecting the correct transformer, it is also essential to ensure that the installation complies with all applicable codes and standards. This includes providing adequate ventilation, ensuring proper grounding, and maintaining appropriate clearances from combustible materials. Ventilation is crucial to prevent overheating, which can degrade the transformer's insulation and lead to premature failure. Grounding is essential to provide a low impedance path for fault currents, minimizing the risk of electrical shock and protecting equipment from damage. Clearances from combustible materials are necessary to prevent the spread of fire in the event of a transformer fault. Regular maintenance is also important to ensure the long-term reliability of the transformer. This includes inspecting the transformer for signs of damage, such as cracks, leaks, or corrosion. It also includes testing the transformer's insulation resistance to ensure that it is within acceptable limits. Any necessary repair should be performed promptly by a qualified electrician. By following these guidelines, you can ensure that your step-down transformer is installed and maintained safely and reliably. Remember that electricity can be dangerous, so it is always best to err on the side of caution and seek professional assistance when working with electrical equipment. Furthermore, consider the environmental impact of the transformer. High-efficiency transformers are available that can reduce energy consumption and lower operating costs. These transformers typically have lower core losses and winding losses, which translate into less heat generation and reduced energy waste. When replacing an existing transformer, consider upgrading to a high-efficiency model to reduce your environmental footprint and save money on energy bills. Also, be sure to dispose of old transformers properly. Transformers may contain hazardous materials, such as polychlorinated biphenyls, which can pose a risk to human health and the environment. Consult with your local waste management authorities to determine the proper disposal procedures for old transformers. In conclusion, installing a step-down transformer in a computer room requires careful consideration of various factors, including safety, code compliance, environmental impact, and energy efficiency. By following the guidelines outlined above and seeking professional assistance when needed, you can ensure that your installation is safe, reliable, and environmentally responsible. Prioritizing safety and adhering to established standards are essential for protecting people and property from electrical hazards. Investing in high-efficiency transformers and following proper disposal procedures can help to reduce your environmental footprint and save money on energy bills.